Good morning, everyone. So today our goal is to finish the intro script that we were working on last class period. So I just want to show you here as a reminder, your folder for the class should look like something like this, where I am right now on the main folder of the class for me. I have an extra folder here that you don't have, but you should be seeing your 01 intro, which is the one that you should have had the script that we were working. And then you should also have the 2024 PPA. In your case, it may have a main on the name since you got that from GitHub. And that has the code that you copied that code to your folder. So remember, do not work on the code files from this folder, as that will change over time. I do want you to copy what you're going to be working on and bring into your own folder, in this case, the 01 intro. All right. So for us to, maybe you already have your RStudio open, but if you don't, you can come on the 01 intro and double click again on that script. It should, if you don't have RStudio open, it should open in RStudio environment. I think in my case, let me close this. It should open your RStudio environment and pull up that script. So last time we stopped right here, and I just as a refresher, so we talked a little bit about R in RStudio, and then we started assigning some values to objects. So we saw that we could assign the result of something, in this case, a calculation. We assign multiple numbers, we assign a string or a character type of object or type of information to this object. We created a data frame, created a matrix, created a list. We check the class of those objects. Remember that objects that have components, for example, data frames have different columns, and lists have different components of the list. There's going to be always a class of that object overall, but also each one of its components or columns will also have their own class, object type class as well. Then we talked about functions, about arguments, about how if you're providing the arguments in the sequence that the function knows, you do not need to specify. Increase this. You don't need to specify your argument name. However, if you're not giving the right order or if you're flipping order, you should specify the argument name to make sure that the function understands exactly what you mean. We talked about installing packages and loading packages. The difference there will always be loading packages here. So one example, I don't know if you remember, but I recommended that you do not keep your environment variables here. So what I expect for you to be seen at this point is no objects in your environment yet, right? And really everything else above here, I don't think we're going to be using any of this code to continue today. What we will need to do is to run this intro again, just so we have that available in our environment. If you recall, this intro object was built with a tribble function, and this tribble function comes from the tibble package. And because the tibble package is not a native package in R, is a package that we have to install like we did last class, I want to invite you to go ahead and load that package. So this would be the first thing really that we need to do today to finish this exercise, is just to run this line of code here, library tibble. So please go ahead and do that. You do not have to install packages tibble. Remember that we only install once, but we load using the library function every time that we open a new session. So if you have tibble already ran, if you ran that line of code and you loaded the package, now we can come down here to the intro and let's just run. Remember, if you have your cursor anywhere in any other parts of this piece of the code, you can just hit Command Return on Mac or Control Enter on Windows, and that will run that entire piece of code. And we see in my case, I have this intro data frame on my environment now. Just a refresher here, if you were having issues building this or coding this part, I guess these lines of code here, remember that it could be because you're missing a comma somewhere. It could be because you did not, so let's say if I did not have soybeans here in quotations, that would throw an error as well. Or maybe you have it in quotation mark within quotation marks, but for some reason you have an extra quotation mark somewhere, that throws errors as well. So it's just making sure you're matching your quotation marks, you have your commas in the right places, and that finally that you close that function with a final parentheses. So these are all very common issues that you're gonna, I'm sure you're gonna make some of these again throughout this course on your data analysis. Always the first ones I look for when I'm trying to troubleshoot code. Okay, so I am assuming you all have this object created on your side. If you don't, speak up and I can give you a moment to catch up. And if I don't hear anything, I'm gonna keep moving. Okay, so after we created this intro object with the name, height, and favorite crop of some of you here in the class, then we were just doing some exploration of this data frame. So we checked the class. Remember that this is a tibble, is a little bit different from a data frame. And I don't know if I showed you yet, and sorry, I'm gonna say this a couple times, that I am teaching 2 courses this semester, and this beginning is very similar between both of them. So if I may tell you something twice, just bear with me here. But so one of the differences here is that Tribble is creating you a tibble, and a tibble type of data frame. So if you get the class, if you recall this, it was a tibble and also a data frame. And if we get, I'm gonna go ahead and run. You don't have to run it, but I'm just gonna recreate the data frame that we created on this step here using the function data frame. Oh, I need the object. Let's see. So if you recall, the class of D is only data frame, it's not a tibble, right? And I just want to make the distinction here. When it comes to plotting, to modeling, to really doing anything else with these data frames, it does not matter if it is a data frame or a tibble. R sees them similarly or the same way. The only time that it matters or that makes a difference is when, especially when we are printing. So notice how if I print here intro, this is what I get. It tells me it is a tibble. It tells me the number of rows, number of columns. It even gives me the class of each one of those columns. So character, double, and character as well. Whereas if I print a data frame, which would be that D object, it does not give me that, right? It just gives me the columns and the rows. Another difference that we're not seeing here is if you have a data frame that has, let's say, 1,000,000 rows, and you print that, if it is a data frame object, it will print all 1,000,000 rows in your console, which is horrible. We don't want that to happen. If it is a tibble, however, it will only print the first 10, I think. So it kind of has some safeguards, especially when it comes to printing, which again is just like, it's not a huge difference. It's just maybe a quality of life improvement on how those objects are printed. But I just wanted to be aware because you're going to be seeing both data frames and tibbles. And again, for plotting, modeling, wrangling, they behave the same. It's just when it comes to printing that they're different. All right, so we use the function summary as well to get a summary. Recall that height was the only numerical variable of the 3 variables here, or the 3 columns. And when R sees a numerical variable, it gives you a statistical summary when you call the function summary, which is nice, especially to find outliers or maybe, well, not outliers, but but observations that don't make sense, right? So if your minimum is unreasonably low or a maximum is unreasonably high, you can kind of see that through here. We talked about the functions head and tail just to get a sense of how the data looks like, and then how to find the class of a component of that data frame, which is just using $sign. Then we talked about how to resample rows and columns using this bracket notation. If you recall, I told you that this is maybe one of the only times you're going to be seeing us in this class filtering rows and selecting columns using the bracket notation. From this point on, we're just going to be using packages from the tidyverse that do this in a more intuitive way. But still, this is kind of our history, so I wanted for you to be aware that existed. Then we installed ggplot2. Please go ahead and load ggplot2 again, so we can keep going, because we're going to be using ggplot function. Excuse me. And then finally, we were in this step here where we were creating a ggplot with the data that you all provided. So just to remind you, this is what intro has. So we talked about what goes on X, what goes on Y, and then we translated that to this part of the code here. So inside a ggplot, plot always starts with the ggplot function. The first thing that we give it is the data frame name. In our case, is intro. Then the second thing is we use this AES function that stands for aesthetics. And this is where we map components of the plot to columns. Whenever you think that you want to map something about this plot to a column in your data set, you should be thinking that you have to have that inside of the AES function. So we're saying here X equals to name, Y equals to height, and color equals to favorite crop. And then we're adding a geometry of point to it. So if you want to go ahead and run this piece of the code, this is what it would look like. So it should appear on this panel here for you. That's what we got. So we got basically here, we have a point for each one of the people that responded to the survey. And because we say color equals to favorite crop, then each one of those points are equal to favorite crop. So I want to show you a few other ways to customize this. So if you think about it, so these are points. So it's a point geometry. Another common thing that we change when we're working with points is the shape. So if I want to change the shape of all the points, I guess I didn't show this on data science one, but let's say if I wanted to change the shape of all the points to a single shape, I would come under geonPoint and say shape equals to, and at least for the shape part, it takes a number, I think it's from 1 to 30 maybe are the options. So I think 1 is the actual dot that we're seeing. Maybe let's try shape equals 2 and see what happens there. Yeah, so 2 changes to a triangle. We can keep playing with this. 3 is a cross and so on. 1 is an open dot actually. So I think that the closed dot is 21 if I recall. No, maybe it's 20. Well, anyways, so if you want to change the shape of everything, you can use this approach. And I just want to show you here quickly. If you just Google like point shapes in R, you're gonna find a lot of different resources, but I'm just gonna open one of them up here. So this is basically what those codes relate to. So actually, I think is 19 what I was looking for. That is the default shape. So these are all the shapes you can use when you're editing your plots. So let's try shape 19. I think that should bring us back to this is the default value. Okay, so what if instead of changing the shape for everything, I wanna map shape to favorite crop as well. So I'm going to delete this. What if I want to map shape of the points to that favorite crop column? And I know that, you know, at least I think here in Athens, everyone in this class is also in my data science class, right? So you've seen this already. So let me see if I can ask someone online that is not part of that class that you would be, you know, you can think about this before actually knowing the answer to. Let's see, Kumar, let me ask you this. What do you think?
Hi.
So just a
Uh,
question, how do you think we can map shape to favorite crop? What would you change in this code to make that happen?
we can add a comma after favorite crop and then add a shape in bracket and assign some specific shape to that which we want to give.
Okay, so you are in the right place, right? So because we're mapping shape to a column, it has to be within AES. It has to be within that function. So you are in the right place. So yes, we write shape equals to, but remember, if we are inside AES, we're not going to specify a fixed value of like, this is the shape, because we want shape to change according to the column. So
Okay.
what would you change here? What would you do here?
I am not sure. I'm not sure.
Yeah, that's okay. That's okay.
Yeah.
Vinicius, what do you think?
Well, for that time, I'm still thinking about. I'm not sure also.
Okay, no problem. Rolando, do you have any thoughts?
No, sir. I don't.
Okay, no problem. So let me help you out here. So the same way that we assign a different color to different favorite crops, we can just same way say favorite crop, and that's all that it takes, right? So then if we run this piece of the code, now we should have both a different color, but also a different shape. And you can see that maybe it's a little bit difficult because it's small, but on your side, as you run this, you would, you know, we can get closer, you can see it. There's a different color and shape depending on the crop. And you can imagine this, that if we had yet another column, so let's say that we had a column that said, I don't know, where you're from, for example, we could use that column and then give a shape according to that. So our plot starts, one of the cool things of ggplot is that it makes it easy for you to start adding a multi-dimensional data set and assigning different variables to different things. Here, we only have 3 columns, and all of those 3 columns are already in this plot. You know, I mean, I think I've made some ggplots where you can add up to like 6 or 7 variables, assigning them to different things in this plot, and making something very, you know, very cool, I guess, or very informative from that perspective of multi-dimensions. All right. So what I want to ask you now is for you to just go ahead and copy this code here and paste that under customizing. Just want to do a quick I want to show you a few ways to customize this plot. There's really a lot of ways this plot can be customized, and the goal right now is not to show you an extensive manual how to do all that, because I do hope that as you get more interested in customizing your own plots, you will, you know, Google things like, and remember, if you're Googling something about making a plot with ggplot, you should always ask how to do X in ggplot, right? If you just say how to change color in a plot in R, you're gonna get answers for different styles of plotting, where ggplot is. So you may get an answer that's not for ggplot, which is not gonna help. Okay, so one of the ways that I want to show you that we can customize this kind of quickly is, let's say if I dislike this color scale here, right? So the red, green, and blue there. So let's go ahead and add a plus here after the geom point. And I want to show you here. So every time that we're mapping a color, shape, size, transparency, anything like that, we do so at the AES level. But if we want to edit that, we start typing scale underscore, I want to take a moment here to stop and just say, if you browse here, it starts scale alpha, but you see color, fill, line width, radius, size. There's a lot of things that we can customize. In our case, we want to customize color. That's one of the things we already changed in this plot. So scale, color, and then as you type color underscore, these are then all the options you would have to change from different color schemes on this plot. I want to show you one here that's the Verities color scale. If you're not familiar with this, this is probably one of the most popular color scales in data science. And the reason for that is it is a colorblind safe scale. So, you know, the colors in this color scale here are safe for people that are colorblind to differentiate. And if you're not colorblind yourself, you know, I think I myself am not, and I think it took me getting to know some people that were to realize that this really makes a difference for people that actually are. And so I think that, you know, if we can do plots that are one, that is a better approach. Okay, so Verities here, we can see there's a B, a C, and a D. This is not just alphabetical order. This is because B is for bind. We're going to see more of this in the future. C is for continuous. So if your data is, if the variable that you are changing color is continuous, you would use that C. So for example, if you're making a yield map, your yield data that you're coloring is continuous, you would use the C option. The D is for discrete. So this is if your variable is categorical or a character. In our case here, favorite crop is what we're changing color. That is a discrete variable. We choose Verities D. So if we run this and we look at the plot, we see now how the colors were changed. They don't necessarily look too great, at least not with this background, but these colors are colorblind safe. And, you know, I just want to remind you again, if you delete this and you type again scale color underscore and hit tab, you can explore different options here and play around with them, see which ones work, which ones don't. For now, I'm just going to keep Verities D for discrete. And also I want to show you how to customize one more thing in this plot, which is the theme of the plot. So what I mean by theme of the plot is basically everything else that's not related to the data. So it could be the color of the background, the color of, I mean, everything here. So going from size of letter to font size, to font type, to even like font. If you want to make the font bold, you can change that on the theme. The color of the background, the color of the lines of the grid that you see behind the points. Really everything about this plot here is controlled by the theme. There are some preset themes that we can use. So let's go ahead and add a plus here, hit return. And if you start typing theme, I want to make a distinction here. So the first function that comes up is called theme. This function here would be the one that you would choose if you want to change these things yourself manually. Like, oh, I want to have control over what is the color of the background that I see here. I don't like this gray color. I want to change myself to a specific color. You would do that inside of this theme function. So if you type tab inside of it, there is like, I don't know, maybe more than 100 options that you can change in this plot. It's a lot of options. However, there are some preset themes that we can make use of them, which if you have theme underscore and hit tab, you're going to see a long list of themes that you can choose from. Well, maybe it's not as long as I was thinking. There are some packages that extend this list, and we're going to probably look into them in other lectures, but these are the ones available by ggplot. So the one that is the default for ggplot is called theme gray. So if we select it, it's not going to change the plot because it's going to look exactly like that because it is a default one. But let me choose a different one here. Let me maybe choose, I really like the minimal, the line draw, light, the BW black and white, the classic. There are some pretty good ones here. I will leave it up to you to explore more of it. But so I'm going to use the black and white one. You can see how that already changed some things here, right? So it changed the background, it changed the line of the color of the lines, it added this boundary here to the actual plotting area. So you can play around with them and see which ones you like and which ones you don't. But this is where I'm gonna leave it. Okay, so the last thing that we're gonna be doing here is let's export this. So even though this plot here is far from being publication ready, there's still a lot of things that we will have to change to make it, you know, a good looking plot for a real professional reason. But I want to show you how you export this. So right now, this plot is just living here in RStudio. To export it, ggplot has this function called ggsave, that it takes the last plot that you printed, in our case is this one, and it saves that to file. So for us to say where to save it, we come inside of ggsave, open and close quotation marks. If you hit tab, that's gonna give you where you are. So because where you are in the path of your computer, this is where it's seeing where we are. And because there is only one file there, it's just populating the name of that file when we hit tab. Even if we had another file here and we hit tab, it would show a list of those files and you could select if you wanted. In our case, we're not trying to select a file, we're actually trying to give a name of this file to be saved. So let's just go ahead and name this file plot1. So this is the name, and then you have to give it the extension. So ggsave takes many extensions. One of them, the one that I use a lot, is called .png. So if you just run that, it should say here in our console that it was saving the file. And if you come on the right-hand side tab and you look under your files tab, sorry, on the right-hand side quadrant and look on your files tab, you should now be seeing the plot1.png right there. So this now is in your computer, it's saved to file. If you click on this file here, you're gonna see the plot that I just exported. And so now that you have this saved to file, which is in the same folder where 0110 intro to our partial is, which should be inside of 01 intro folder that we created in the beginning of this exercise. Now you can pretty much take this this file and, you know, use it in presentations, in reports, or whatever you need to use it. So now it's already somewhere that you can move it around. Okay, so I'm gonna tell you about an assignment and I'm gonna leave it for you to finish after class. We're not gonna have time to do that in class, but just to tell you what I'm asking you to do here is I want you to go back and play with this code that we created here under customizing. So I want you to come here and explore the scale color options. And I want to play around with some of them, see which ones you like, see which ones work, which ones don't work. And then choose one that is different from the one we are using in class. So we're using the radius D. I wanted to choose a different one. And then do the same with the theme. So go under theme, delete that BW, hit tab, look at the different options, choose one of them. And then whatever you choose, you know, make sure it's not the same one as we're doing here in class. Once you selected a different scale color and a different theme, export this again using ggsave. And I just want you to add your last name at the end of that file type. And then once you do that, I want you to upload this to a GitHub issue that I'm going to open right now called assignment number 1. So I'm going to go there and open just so you can see where I want you to submit this. I think, let's see. So I'm just going to go here on the GitHub for our class. And under issues, I'm going to create here a new issue called assignment 1. So now the issue is created. Whenever you're done doing your assignment, you can just come here and upload the PNG file that you exported. So you can just click on that attach files and upload it to here. And you have until before our next class, which is actually not gonna be Monday. Monday is a holiday. We're gonna be meeting again on Wednesday. This assignment is very simple, does not take time. If I were you, I would just get this out of your to-do list as soon as you can. But you have until next Wednesday before class to turn this in. Okay, so let's come back to RStudio. That is the assignment. And this pretty much wraps up our exercise today. Something that I may have forgotten to tell you last time is, remember that we do not save our environment, but we do save our code. To make sure your code is saved, you can just click on that save button, and this saves all of your changes to the script. And you can kind of see, like, even if I just add an extra space here that was unsaved, now the name of the file here changes to like a light gray. And if you click on save, that becomes white. So you know things have been saved, and you do want to save your script. Remember, if you have the script and if you have the data, you should be able to reproduce all of your objects on your environment. So that's why we do not save objects, because they're actually byproducts of your code and data. So we don't care about objects. We can always recreate them if needed, if you save your code and you have the same data as you used the first time. Okay, so this wraps up this exercise. So the next thing that I want to do here with you is,
I have a question.
yes.
I'm sorry. So when I on GG save plot one, when I run it, when I print it, it gave me an error.
What is that saying?
It says error in GG save plot one PNG will not find function GG save.
Okay, so ggSave comes from ggplot too. So, I mean, are you able to make the plot?
I don't see the plot over here to the right.
Yeah, I don't think you're being able to make the plot, and that's probably because you need to load the package first to make those functions available. So if you run the library ggplot2 function first, and then try to making the plots, seeing them on the side, and then exporting, that should work.
I thought I did. Let me run it again and get us going. Okay.
Is that working?
Yeah,
Okay.
yeah, it worked.
Nice. Yeah, always is a good recap that, we should, for us to be able to use the functions that are inside packages we install, we need to load them, and we do that by using the library function every time we open a new R session.
And this might be a stupid questions, and I'm sorry, y'all, if you think this is stupid, but so when you print and you continue type it on that line, it will be updated on the bottom, right? You don't have to run it again, because that's one of the things that confuse me. Then when you're talking and you said, "But I can do something else," I tried to run it again. It keep giving me errors.
So I'm not sure I got the situation.
Let's- All right, may I share the screen?
Yeah. Let me stop sharing, and I need to give you permission. Yeah, and just to make it clear, there is no stupid questions, right? I mean, this, especially if you're new to R in RStudio, this can be tough. If I can help you in class, I will definitely do that, especially because more people may be having the same issue. If it's something more complex, we may have to wait for after class. But yeah, feel free to ask questions anytime something's not working.
So if you run this theme black and white, before you get to black and white, and you said if your scale color varieties or something,
Mhm.
He said, you go ahead and delete this and say you can, when I explain something else, you don't have to run it, but I just keep running it and keep giving me the error. So even after you run, geom point plus right here,
Mhm.
you print that one and then you have another thought and then you'll delete it and it will be updated right here. And then, so that's what I got confused. I thought you have to be running every time to be able to update in the bottom.
Well, so if you, let's say, if you make a change there, so if you decided to change theme b underscore bw to something else, so if you're changing just in the script, it's not going to update the output yet. It's just the script that's changed, right? So remember that the script is where we develop our code, but then when we want to see the effects of that, we have to send it to the console, and the console is what interprets it and then updates the output, right? So you would have to run the code actually to see the effects of that. So just changing the word there and not doing anything else is not going to change anything. Is that your question?
Yeah.
Yeah.
Stop.
Yeah, thanks, Rolando.
Thank you.
All right, so the next thing, well, can you, everyone online can see my screen? Okay. So with that, we finished this exercise here. Make sure you save your script. And before we move to the next step, I just want to call your attention to something very quick here, which is if you look here on the right upper side, it says project none. I just want you to notice that. We're not going to do anything about it yet, but I just want to make you aware of that. Okay, so you can go ahead. If you saved your script, you can go ahead and close your R session. We're not going to be working on this anymore. And now I want you to focus back on the folder that we have for the course, right? So I am seeing the 01 intro. That's where the plot is. That's also where the script is that we just developed. I want to go back to the main course level. And I want to create a new folder here that I'm going to call 02 Wrangling. I want you to do the same with me here. So I am gonna slowly introduce a new topic here that is related to data organization, reproducibility. It's not specific to precision ag, but it is definitely something that anywhere you have data, you can benefit from what I'm going to show you next. And this has made a great difference in my R learning curve after I learned this simple yet very effective tip. So notice how 01 intro was just a folder with some files, right? Imagine that this is your master's or PhD or undergraduate research, and you have, I don't know, 10 data files, maybe another 5 scripts, and then you're creating tables and plots out of those. And then you end up with this folder where you have, I don't know, 30 different files all mixed together. The names are not making any sense in the alphabetical order as far as looking at that list and making sense of what they are. And it's just a huge mess. I don't know if you've been through this. I definitely have during my master's. My folders were very messy. And if you have not, great for you. Maybe try to figure something out better. But if you still do that to some extent, I do want to propose here an alternative to that. So if we go back now to the main folder and go inside 02 Wrangling, we're going to be creating a subfolder structures inside of this 02 Wrangling that will help us organize our files. So the first one, so if you can just go ahead and create the folders with me. The first one is data. This is where any data that serves as an input to your analysis is going to live. So this is where you're going to have your Excel files, your CSV files, your shape files, whatever it is that you're using, they're going to live under this folder. The second folder is going to be called code. So this is where any code that we develop is going to live, right? So if it is a .r script like we just did previously, if it is an R markdown, a Quarto file, this is where that's going to live. And lastly, we're going to create one called output. So output is the folder where you're going to output your figures. Even if you're making a table in R and outputting that, that's going to come here. And so this way you can see that we keep the different components of an analysis separated on their own subfolder to make this easier to understand and to organize. To me, this is the minimum subset of subfolders needed for an organized analysis. You may require more on your side. Maybe sometimes I have an extra one that I call resources, where maybe it's like, oh, I have this manual I found online that's important for this project. I paste that file under a resources subfolder. Maybe you're already working on a manuscript and you want to have a folder here called writing, where you actually are doing the writing based on the outputs of this analysis. So you may adapt this to your situation. You may have more folders, but I think that these three are the minimum three that I would suggest you have for every single analysis you do, regardless if it's in R or not, because this has nothing to do with R, at least not yet. Okay, so these three subfolders are important. I want us to now leave your folder, and this is always what I will ask you from this point on. Every time I tell you, hey, I uploaded this script, please go ahead and create a subfolder structure for this. I will tell you what the name of the main folder is. So it would be maybe like 03 plotting or 04 yield monitor data, something like that. But then this structure is what I mean when I say create a project for this exercise. Okay, so one more thing that I want to show, one more concept that I think is also very, very important, yet very simple and easy to learn, is if you just launch your RStudio, I mean, if you already have RStudio launched, you can just go to that window, whatever it is. If you don't have it launched, like I didn't, you can just go ahead and launch it. So notice how on my side, and then most likely on your side as well, here it says project none. So there is no project that this RStudio window represents. I want to show you the concept of an RStudio project. And I guess before I show you how to create one, I just want to make the point of why I think they're so important. You will for sure be working with different analysis at the same moment, maybe the same day, you know. So for example, on my side, so my website is built with RStudio and Quarto files, which means I have my own project for my website, which is different from the projects I use for my data analysis for the projects that I have with my students. So if you click here, you get a list of the most recently used projects that you have, and you can quickly browse through them and change through them. So let's say if I want to go here to, there's analysis we're working on for a student in Tifton that we're collaborating with. So if I come here and I click on this project, my whole RStudio view is changing. Now the project name is appearing here. Remember before it was preview none. Now I have the project name appearing right there. When we are in an RStudio project, which this is what that's called, I have this blue R button here that if I click on it, it takes me to the main folder of that project, which again, you see the same folders I'm showing you, code, data, and output. And let's say this is the code I'm using for this student. It is a Quarto file. We have not seen that yet. So if you're not familiar with it, don't worry. But here's the code. If I need to see, here's the data. And here are some of the outputs. Awesome. So if this student has an issue, they need some help with something they're doing, I can come here, do that quickly, send them the analysis results or whatever they need. And then I want to go back to, a different analysis. So let's say here I have this US cotton weather analysis. So I can go there, click on that project link that I have here on my recently viewed projects. It will reopen a completely new RStudio session with a completely new set of files, right? So if I come here again on my R blue button, click on that, I see here this project has a few more things going on, but I still have code, data, output, and you can see that, you can really switch quickly from project to project, which I think is very important. The more things you start having on your plate, in the beginning, before I use this, I would have sometimes, I don't know, 10 scripts open on the same RStudio window, each one of them being from a different project. And it then becomes a nightmare if you want to flip, like your environment becomes messy because now you have coming from one project that have nothing to do with objects from a different project. So this way, using RStudio projects helps you keep very focused on that specific project and not be affected by other things that may be going on. Okay, so I want to close. This was just, me showing you what RStudio projects are and what they do and why I think they're important. So let me just come back to my preview none view of RStudio, which I believe is what you're seeing as well. Oh, come on. Let me see if I can close this project. For some reason, it's coming back to it. Okay, project none. So let's go ahead and create an RStudio project for our next coding exercise. So if you please follow along with me, because this is going to have a few steps that if you miss them, you may get lost in the way. So if you come here on this project none, let's click on that, and then let's click on new project. For some reason it's taking a moment on my side. Okay, there we go. Okay, so you see here that we have a few different options. For this class, we're always going to use an existing directory. I think it's a little bit easier if you already set up your directory like we just did, like the 02 wrangling data code output. So this is the option we want to use. So click on existing directory. It's going to give you the option to browse to that directory. So please click on that browse button. And I want you, your path is going to be different from mine. So what I want you to do is to find that 02 wrangling folder that we just created and navigate to that folder on your side. I will do that as well. What's going on? So this is where I want you to be. I want you to be at that 02 wrangling level and seeing your code data and outputs there. So I do not want you to be inside code or data or output. I want you to be seeing this main level of that 02 wrangling folder. When you are there, click open. And then create project. So this is basically resetting you kind of relaunched your RStudio window. And you can see here that now we have that 02 wrangling on the top right. That's how you know that you are successful in creating your project in that folder. And we see now that, so if I come on my actual data, like my data management system, my computer, so not in RStudio, but in my actual folder, I see that now there's a new file here called 02 wrangling.rproj. So this rproj file is basically what sets up your RStudio projects, and is basically whenever I was browsing through my list here of recently viewed and I was clicking on them, it was basically launching that rproj for those projects. Meaning that, at this point, I don't know, I have hundreds of projects that I created over time. So this list does not represent all the projects I have. So if you have a project that is not appearing on your recent projects, you can just go to that folder and double click on that rproj icon to launch that project. I want to give a tip here that I see happening a lot of times. So we're going to bring in code here that we're going to develop, and we're going to paste that code under code. And what I see happens a lot of times that gets students confused is, so let's say they have RStudio closed, and instead of opening the rproj icon to launch that project, and then coming through files here to browse to the code and open the code that they want to use, instead of doing this, they would come under code and double click that script and launch a preview none or project none RStudio window. So in that way, you're not working on your project and all the benefits of that project are not being fulfilled. So what I'm trying to say is every time that you're going to start working with that specific project, do so by launching the RProj icon instead of double clicking on the code that launches on a different RStudio window that may not be related to this project. Okay, so we have things set up here. So we have our project set up, the code data and output. I want to come back here and I want to tell you that last night I uploaded a script that we're going to be using for doing data wrangling. So if you want to go on your browser, you go on the GitHub page for our course. So that's again github.com/Leo-Bastos/2024_PPA. And just to give you some background as well. So PPA, has nothing to do with the name of the course this semester, but is the acronym of the name of the course as it was approved, which I'll be teaching forward from next year onwards. That's Programming Precision Ag. So that's why PPA, if you were wondering. Okay, so if you go there and now you go on code and download zip, you're gonna download again this repository. You're gonna see that now there is a data file under data. That's the soybeans.xlsx, and there's also gonna be a new code under 04 class code, a new partial code that's called data wrangling. So please go ahead and download the whole repository. So remember, it's not easy to download individual files. So you have to download the full repository, and then you bring that into your main course of the folder. Let me get to mine. Right. So again, you see on your side, once you download that, you're going to be seeing 01 packages, 03 data, and 04 class code. Before we move files around, I just want to stop for a moment and ask, was everyone able to download it and seeing the at least 01 packages, 03 data, 04 class code on your computer? If someone was not able to, let me know, because you will need to, and we can wait a moment. All right, I don't hear anything, so I'm going to keep moving. What I want you to do now is remember, the 2024 DSA main is not where your personal files should live. This is just a place where you retrieve what you need. So let's go first on 03 data. Oops. Oh, sorry, I'm in the wrong class. So let's go on 03 data. There's a 02 soybeans data set there. Let's copy that. Get outside of that folder, get outside of 2024 PPA, and let's go inside of 02 wrangling and paste this in the data folder, right? So data lives on that data folder. We're gonna do the same now for the script. So I wanna get outside of the data folder of this project, get outside of the project, be on the main folder of the course, go inside of the GitHub repo folder, go inside of the 04 class code folder, copy that 0112 data wrangling partial.rmd. So copy that. Go back one time, two times. Now we are at the main course folder again. Go inside 02 wrangling, go inside of code, and paste this script there. Okay, so, if you're still working on it, no worries, there's no rush. I just want to remind you that for you to be ready to go for next class period that we're going to be doing data wrangling, you should have the 02 wrangling folder on your main folder of the course. Inside of that 02 wrangling, you should have the code, data, and output subfolders. You should have created the RStudio project to be appearing up there. You should have the R Markdown code inside the code folder. and you should have the soybeans Excel file inside of the data folder. This is what you need, and we're not gonna take time next class. What's that? Oh, okay. Oh, wait, our class ends at 10. Yeah, sorry about that. Sorry, everyone. I thought we ended at 10:10, so that's why I kept going. Sorry, Ujwal. Yeah, so let me wrap up here. So yeah, that's what you need to have to be at for us to get started straight off the bat next class that we meet. All right. So let me let me open an attendance issue. So I came to our class GitHub repo. I'm gonna open a new issue. And I'll call this attendance January 12th. Please go ahead, drop me a note to let me know that you were in class today. And thanks everyone. Sorry that I went over time. I thought we were actually going till 10:10. Yeah, and let me know if you have any questions, any issues. I can help you out. And if not, then I'll see you next Wednesday.